Alright, these are the notes from today on multiplying and dividing keywords and other rational number operations. This is a reminder for the integer song, multiply or divide. It's an easy thought, same signs are positive, different signs are not. And then these are some of the keywords that we came up with in class today. If you do not have this filled out, please pause this video and copy these words here. Now, then on the next page, we went through this example in class. We discussed fractions, adding and subtracting fractions. Finally, common denominator first. Adjust your fractions so the denominators are the same. And if you change the denominator, you must change your numerator too. Add the numerators and whole numbers if they're there, and then keep the denominator the same. Simplify if possible. I mentioned the do-do rule down here in our example. So we had 1/6 plus 3/5. Whatever I do to the 6 to get 30, I must do to the 1. And whatever I do to this 5 to get 30, I must do to the 3. So that's the do-do rule. Whatever you do to the bottom, you do to the top. And whatever you do to the left, you do to the right. And whatever you do to the inside, you do to the outside. Down here, I converted 4 1/8 minus 2 1/2 to improper fractions so that I didn't have to borrow. It gets really messy and ugly when you have to borrow for fraction operations. So I just converted them to improper fractions, found a common denominator, which was 8. This fraction did not have to change. Some of you talked about 16 being a common denominator. Yes, it's correct, but it's not the least common denominator. And then I applied the do-do rule here. 5 times 4 was 20, so I subtracted 33 minus 20 gives me 13, and then I was left with 1 5/8. The next part talked about multiplying and dividing fractions. If your fractions are mixed numbers, you definitely must convert first. That is the only way to multiply fractions and divide fractions. You have to have improper if there's a mixed number. Multiply the top times the top, the bottom times the bottom, simplify. For dividing, you have to do one extra step. You must multiply by the reciprocal. So you keep, change, flip, and then apply the fraction multiplication rules. Always simplify if possible. The examples on the next page are here. So I'm going to do 13 over 3 times 2 over 15. 13 times 2 over 3 times 15 is 26 over 45. And I cannot simplify that. Had I known that, I would have simplified earlier. This is prime, this is prime, this is prime, and this is composite, but the only factors down here would have in common with 3, but I cannot cross them out because they're not one on top of the other. Down here, I have a negative times a positive, which is going to give me a negative answer, so I need to make note of that. Negative. And then I would need to apply the Texas method or get mad. I like to call it the treasure under the church. Treasure is where the X marks the spot, and the church has a cross on top. So 2 times 2 is 4, plus 1 is 5. So this problem or fraction becomes negative 5/2 times 4/7. My answer is going to be negative. 5 times 4 is 20. And 2 times 7 is 14. I can simplify this. This is negative 10 times 2 over 2 times 7. Cross out the 2's. I'm left with negative 10 over 7, or negative, find out how many times 7 goes into 10, which is 1 whole, and then I'll have 3/7 left. 2 answers here, one in improper form and one in mixed number form. Over here, I have to convert, and then I have to keep, change, flip. So 3 times 2 is 6, plus 1 is 7, over 3, times, change this, negative 2 over 3. Negative 2 times 7 is negative 14 over 9. This is one answer. And if I convert it to mixed number, 9 goes into 14 one time, and that would be negative 1, and then I would have 5 left over out of my 9s. Lastly, I have negative 7/8 divided by negative 14/3. These are negative numbers, so if they have the same sign when I'm multiplying or dividing, I will get a positive answer. I will write negative up here. Negative. And then I would keep, change, flip. Negative 7/8, 8 times negative 3/14. 7 times 3/8, and then I will break 14 down into 2 times 7 so that I can simplify. Cross out your 7 on the top and on the bottom, and then I'm left with, remember this is going to be positive, 3/16. Done with that. Alright, the next part, decimal operations. If you are adding and subtracting decimals, line up the decimals, add the zeros as placeholders, and work it out. Multiplying decimals. Multiply as normal, count your decimal places in the problem, and ensure that your product has that many decimal places. That means however many you counted in step 2 needs to be applied to your answer. Dividing decimals. You're writing your division problem in standard form, and then you must make your divisor a whole number. If you move your decimal in the divisor, you must move the decimal in the dividend the same number of times and divide like normal. Only 2 decimal points are needed in a decimal division problem, 1 in the dividend and 1 in the quotient. So I'm going to start with this problem here because it's the longest and it needs some work. I'm going to rewrite it as 3.4 into 55.318. Okay, so we can't have the decimal here on the outside, so we have to move it one place to the right. And then whatever we do to the outside, we must do to the inside. So move this decimal one place to the right. So my new problem is 34 into 553 and 1800. Now I need 2 decimals, 1 in the quotient and in the dividend. So I like to write out my multiples of the divisor so that I can easily multiply. So 34 plus 34, this is the first multiple, the next one is 68. 102. 8 plus 4 is 12, carry the 1, that's 10, plus another 34 is 136, plus another 34, 0, carry the 1, 170, plus another 34 is 204, plus another 34 is 238, plus another 34, 2, carry the 1, 7, 2, plus another 34, 6, 3. And I need 9 multiples because I can't write 2 digits up here in a place. Excuse me. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I divide. 34 into 5 won't work, so I cannot write anything on top of that first 5. But 34 into 55, I have one of those. 1 times 34 is over here. And I subtract 4 minus 5 is 1, 5 minus 3 is 2. Bring down your 3. Now I can work this out in 34 into 213, and I like to write another division problem there so I know that the next step is to divide. So I look over here and see how many times 34 goes into 213 before passing it. So that's this guy right here, and that's 1, 2, 3, 4, 5, 6. 6 goes there. 6 times 34, already done for me. 204. 213 minus 204 is 9. Bring down the 1. Sorry, I had to check my work. 34 into 91. is 2 before it passes it. 2 times 34 is 68. So again, this was divided by 34. 91 minus 68, this is 11 minus 8, which is 3, and this is 8 minus 6, which is 2. And bring down the 8. And that's 1, 2, 3, 4, 5, 6, 7. So this answer is 16 and 27 hundredths. And that is how you divide with decimals. The last step, of course, would be 7 times 34, which is 238, and you have a remainder of 0. Okay? All right, so for adding decimals, because this is a little easier, I'm going to put 5.1 over 6.758, and then I'll put zeros here as placeholders, and I'll add as normal. That's 0, 5, 7 plus 1 is 8, bring down my decimal. 6 plus 5 is 11. Done with that guy. Over here, I would subtract 7.798. Excuse me. Still line up your decimals. 5, 2, placeholder, placeholder. 8 minus 0 is 8. 9 minus 0 is 9. 7 minus 2 is 5. And 7 minus 5 is 2. Done with that one. Make your box look a little better than this one. And lastly, 434 and 31 hundredths times 2 thousandths. So I'm going to put 431 on top, and then I'm going to put 002 on the bottom. Usually I will put the number with more digits on top, but they have the same amount of digits, kind of. More digits on top. And then I would multiply as if there are no decimals. So 2 times 1 is 2, 2 times 3 is 6, and 2 times 4 is 8. Now I will bring back my decimals. There's one here, and there's one here. And I will count the number of numbers after each decimal. So that gives me 1, 2, 3, 4, 5. So I need 5 decimal places. So I'm going to go 1, 2, 3, 4, 5. My decimal will go here. I will fill this with zeros. My final answer is 862 hundred thousandths. This is a tens place, hundredth place, thousandths place, 10,000th place, 100,000th place. Done. Okay? Make sure you have this copy for your notes. It is imperative that you see an example and what you're supposed to do. Show all of your work. Like I've been telling y'all in class, if you're not showing your work, you're telling me that you're smarter than I am and that you can do this off the top of your head. Please, please, please show all work, examples as well. Have a great evening.